Hi guys, this is the second tutorial in AI agent series. Here we will continue setting him up from where we left off in the first tutorial. We will populate all the fields inside Edit Humanoid AI Animation wizard. And we'll prepare the agent for first playtest at the end of this video. So let's import all the downloaded animations into the project. Let's drag all of those clips into the project. And let's close the window after that. And if we select any of the clips here, like this bayonet stub, let's take a look at it inside Inspector, and let's expand bayonet stub, and here we see two animation clips. One is bayonet stub, another is mixamo.com. Bayonet stub clip doesn't have any keyframes in it, but mixamo.com is the one that has all of those keyframes. And this is the case with all of the imported FBX files. The clips with names on them will not have any keyframes, but the ones that are saying mixamo.com are the ones having those keyframes. So what we will do next is we will take all of those clips and we will modify them in a couple of steps using automation dialogues and wizards provided with this kit, so that we would end up with a new set of clean clips stripped of all the unnecessary stuff like skinned meshes, materials and textures that came with imported FBX files from Mixamo. So let's go to Tools, Mobile Action Kit, Humanoid AI, and rename and modify animation dialog. Let's dock it to the right side of the editor, and we'll dock the inspector to the left side. And now we are ready to proceed with the first step of modification of imported files. Let's pick bayonet stub. Here the game object field is populated with imported file root object, and here we have a field for name. Let's change it to melee attack 1, and let's press the rename game object and animation clip button. Here you can see the melee attack 1 is the new name of that imported file, and it has only one animation file left in it that has all the keyframes and plays them back correctly with the same name applied to it as well. And now we'll have to do the same for the remaining files. Let's pick the next one, SWAT cover idle. Here we'll call this one halt right. The next one would be the opposite of that, which is halt left. Let's take next one, crouch idle, which will be crouch aiming. Next one will be crouch fire, and another one death from headshot. Next one would be death animation 1. Next one, death animation 2. Another one will be death animation 3. Let's pick next one, firing rifle. We'll call it stand fire. Next one is hit impact, so let's drag it in and call it body hit animation 1. Next one we'll call body hit animation 2. Another one is run backwards left. The one after that would be run backwards right. Next one is this jog backward. Let's call it run backwards. The one after that is jog forward diagonal. Let's see which side. Here the guy goes forward left direction. Okay, let's call it run forward left. Let's pick another one. Here this clip should be opposite direction. Yep, so this one would be run forward right. Next is jog forward. We'll call it run forward. Strafe left we'll call run left. The next one is run right. The one after that is for reload. We'll call it crouch reload. And the next one would be for stand reload. The one after that would be stand aiming. The one after that would be rifle idle. Here we'll call it stand idle. The next one would be for the punch, which we will use for the melee attack animation. So we'll call it the melee attack 2. Let's take the next one is rifle run, which we'll call sprinting. Let's take the next one, rifle turn 1. Let's play it back, and here we see the guy turns to the left, so let's call it turn left. The one after that, let's look at it. The guy turns 180 degrees, so let's call it this turn 180. The next one is a turn and kick, and we'll trim that clip and we'll call it melee attack 3. Next we have rifle turn. Let's play it back. This one is turn right. The one after that we'll call walking. Next is strafe left. Let's look at it, and we'll call it just walk left. The same thing for the strafe right, walk right. Next one is the kind of taking cover in the left direction, so let's call it stand cover left. This one is the opposite, stand cover right. Next is the throw. We'll call it grenade throw. Another one is walk backward left. Let's remove the prefix. The same thing for walk backward right. Same thing for walk forward left, also removing prefix and the spaces. And for the walk forward right is the same procedure. Next one would be just walk backwards. Next one we'll use for the body hit animation 3. And now we're done with the clips that needed to be renamed, and we're ready to get to the second step. Let's close this window, dock inspector back to the right, and go into edit animations wizard, where we will populate all the fields with their respective clips. Let's find one for base stand aiming animation. It's this one. Next would be stand fire animation clip. And next here, this one. Next is the stand idle. Another one is for the stand aiming. Next one for the base crouch animation. Base crouch aiming. Crouch fire. This one here. So as you can see, in a similar fashion, we'll put all those clips into their fields. Next is stand cover left, stand cover right, stand cover neutral. We'll use this stand idle. For the run forward, where is it? Run forward. Run backward is here. Run left. Run left. Run left. Where is it? Run left here. Run right. Run forward. Forward left. Run forward. Backward right. Run backward left. Next is walk forward. Where is it? Here. Where is the SWAT walking? We forgot to rename that clip, so let's go back through the process once again just for that clip. Rename and modify animations. Let's drag it inside and rename it to walk forward aiming. Apply it. And then let's drag this renamed clip into the field. Next, let's find walk right animation clip. Walk left. Walk backward. Walk forward right. Here. Walk backward right. Let's put it here. Walk backward left here, and walk forward left here. Where's the grenade throw? Let's go up. Here's the grenade throw. Melee attack 1. Let's find it. Melee attack, melee attack. Let's see here. Then melee attack 2 and the melee attack 3. Now, as we done populating the combat animation fields. Let's proceed to the non-combat ones fields. Let's take a look at this one, walking. Let's look at it. We'll use this clip for wandering, patrolling behaviors, which we'll cover in this AI series. Let's put it inside walk idle. And then upper body idle animation clip, we'll reuse this stand idle. Next one, we'll take this stand aiming and put it inside the upper body scan animation field. Next one is turn left, then turn right, turn forward. We'll use this one, turn 180, and we'll use it for the turn backwards too. Let's next upper body hit clip 1. Let me put inspector back to the right side. Let's preview it. Yeah, that's the correct one. For a moment there I thought it was the wrong one. Let me put another one for hit animation 2 and body hit animation 3 here for the upper body. For the lower body we will put those same animation clips for clip 1 and clip 2, but for lower body hit animation clip 3, as you can see here in this example, the guy is walking, so we will use other clip just for that lower body layer. We'll take the idle animation, stand idle. For the halt animations for the lower body and the upper body, let's find those clips here. Here we put this halt left, then the halt right, and for the upper body layer we'll use the stand idle for both of those. Those last 4 clips will be used for the situations where AI will be utilized as a leader of a player, sort of a guide through the level, when he will have to stop and wait for the player to catch up with him at a certain halt points. We'll cover this behavior later in the series, but the main takeaway here is that those upper and lower layers will contribute to the final appearance of those animations in the game. And now, as we finished populating all those fields here, it's a good time for us to further optimize those important animations. And let me open the containing folder where those files are stored, and its size, if we look into it, it's 255 megabytes. Because all of those files have a lot of extra information that we don't need, such as materials, textures, skinned meshes, and the only thing we need is the animation clips themselves without all of those extra files that are packed inside of those imported FBXs. And there's a way for us to do this very quickly with the push of a button that will automate this process for us. And this button is this duplicate animation clip and modify import settings. So what it does when it is pushed, it goes through all of the files, the animation clips from which are placed into those fields above it. And it duplicates them first, then takes those duplicates and extracts those animation clips from them. It then deletes all of those extra files from those copied FBXs, skinned meshes, materials and textures, and after that it modifies various settings of those clips, such as the import settings, the animation types, avatar definition, settings inside animation windows themselves. Right now you can see none of them are configured properly. So it will take care of all of that for us once we push that button. And this approach of importing those files from Mixamo in such a format that they are here right now with their skinned meshes instead of importing just the clips themselves spared us the trouble of dealing with some issues like twisted toes and all kinds of other problems, many of which are sometimes impossible to fix inside Unity. And the approach used here provides us the most predictable outcome. So let's push that button, and here it does all the tedious work for us, going through all of those clips one by one and fixing them, and then renaming them to match the names of those fields themselves. Let's look at the results, and here you can see that all the fields got repopulated with newly created clips. The names of those newly created and tweaked clips are exactly matching the names of their respective fields that they have been put into. Like for example, this first one here, walk idle animation clip, the one after that, upper body idle animation clip. Let's click on the first one and we can find it sitting inside project. And inside inspector we can see that clip is already configured to work with the project with all the right checkboxes checked and drop down options already set for this clip, as well as all of the other clips that just got created. Let's check another new clips too, like this one. And the upper body hit animation clip, here we can see that the settings are a bit different between the clips that should be looping and the other ones that should not be looping. So now we can take all of the clips that contain all the extra stuff that we don't need and delete them, except the death animations, because we did not use them yet, we did not optimize and apply them to the project yet. So we'll take all the other ones, let me just prepare them, and we will get rid of all those clips. Let me go through this. Let's select all of those. I should have probably done it inside folder itself. That would be much faster, but there are not that many of them anyway here. So let's delete all that except the death animations. And now we're left with the most of the contents of that folder being the newly created clips. And let's go to the hierarchy and drag the soldier model inside the humanoid AI animator controller field. And now let's deal with the remaining death animations. Let's select them first and then we'll go and change their import settings. Let's set their animation type to be humanoid. Let's apply it. And we'll fix the animations for them manually one by one. Let's select here the bake into pose option and based upon original. Same here. Let's apply it. Then the same settings for the second clip and for the other ones too. And let's optimize them now, but this time we'll do it a bit differently. Let's get to the tools, mobile action kit, humanoid AI and duplicate animation clip option. Let's dock it. And here from death animation 1, let's drag that animation clip itself and let's rename it to death animation 1. And once we push the duplicate button, we created a duplicate of that clip already renamed and with the inherited settings of the source clip. And we'll do the same for the death animation 2. Let's put it in here. change the name, duplicate, and then death animation 3, and the last one is the death from headshot, and duplicate. And now as we're done, let's close this tab and let's delete the imported clips. Death animation 2, 3, and the headshot. So let's delete them, and we're left with optimized versions of those clips, which we will now drag inside death animations section of the wizard and see them appear inside that section as we are dragging them in. Let's put the rest of them here, and the last one. You can see the approach with death animations is different from the other ones we did. This is due to the fact that there can be as many dying animations as you want inside Animator Controller to randomize the look of dying AI agents as much as possible. And this is a very good option in case you want to use actual animation clips for AI agent dying events instead of the Unity Ragdoll physics engine, which would take care of all of that on its own but at a higher calculation costs, which can be a problem if you have a lot of them dying at the same time. So let's click that button to add those death animations to Animator. And as it did that, we can see the confirmation inside the console that animation clips assigned successfully. And now let's open up the animations folder again, and we will compare its final size to the one we had before. So here it is 34.2 megabytes, whereas before we had 255.1 megabytes. So by going through those optimization steps, we have greatly reduced memory footprint. And now, as a final step of this optimization process, let's save those changes to the Animator. So let's press Save New Animations to Animator, which will save all the changes and close the wizard for us automatically. Let me put back Inspector to the right, and let's check how they play back in the scene window. Let's push play. Here is the idle animation. Let's pick another one, dying, and shooting animation, and let's see, aiming animation. And here might be a good place for you to further tweak the position of the weapon if you find it to be a little bit off, because that I think it's a little bit too much inside the left palm. So let me just turn it up a bit. I guess it's okay, maybe a little bit like that, and it will store those tweaks, so when you will make a prefab out of it later, it will have a corrected position for the weapon. Let's close the animation window. So now, as we have dealt with the animation stuff, let's proceed further to configuring this AI for his first combat engagement with the player. His team ID is set to be 2, as the player always will have team 1 ID in this series. So that's a general rule. Player and his teammates are to be team 1 and the enemies to be team 2. And let's add a couple more elements to this AI. Inside the find enemy script, there are reference fields for field of view and hid to unhid enemy switcher game objects. So let's expand our AI hierarchy inside neck, head, and bone. Create a child game object, and we will call it field of view. And let's now position it somewhere in front of the eyes, like that. Let's check the orthographic view here. It's okay. Something like that. Yeah, that would be a good position for it. When we will set the limits of the field of view angles for this AI agent to achieve a realistic human vision cone. And let's now duplicate this game object to create a hid to unhid enemy switcher. And let's position it further away in front of the head, maybe a little bit more, like that. And this switcher game object will be used in combat situations where there are multiple enemies. It will play a critical role in functionality of shifting fire from the enemy that just got hidden behind geometry, be it dedicated cover or building or any other kind of geometry in the level, to other closest enemy which is not hidden by any geometry, and thus becomes a next valid target for this AI agent to attack. So he will take aim at that remaining guy which is in the clear view and will start shooting him instead. So let's drag those created game objects into their respective fields. And next let's add a couple game objects more to be used inside humanoid visibility checker. Visibility obstacle checker will have to create, and inside the detection validator we'll just drag an existing bone. And so let's duplicate field of view and we'll rename it to vision obstacle enemy raycaster, which will play a very important role in general detection behavior during non-combat states. It becomes a factor of visual detection itself, because if the enemy is within the field of view as well as within detection range, the next condition would be to check whether it is in direct visibility in order to trigger the visual detection. And during the combat state as well, it will play an important role in triggering enemy pursuit behavior if enemy runs away to hide himself behind the building or any other kind of game geometry, which we'll cover later in AI series. So let's drag a vision obstacle enemy raycaster into its field, and let's drag the head bone inside detection validator field, the purpose of which will be explained in a greater detail in a later tutorials. And now let's tweak the shooting point for this AI's weapon. Let's expand the weapon in the hierarchy. Here is the shooting point. Let's adjust its position in front of the barrel. That looks okay, and let's now make the scale of it to be 1:1:1. That's okay, and now let's scroll down, and here we have a list of missing components that we will have to add into this paragraph. First is the weapon mesh itself. Let's drag it in here. And here, after that, we need to add 4 missing animation clips. Let's go back into the animations and find the first one, stand reload clip, put it here. The next one is a crouch reload, then stand fire clip, and the crouch fire clip. Let's copy the transform of that shooting point, and we'll paste it inside spine rotation point. And let's make its scale to be 0 in all axes, which is important for this spine rotation point to work properly inside the spine rotation script. If we open the script, you can see where it is located in it, and it's crucial for its scale to be 0. Next we will create a bullet shell spawn point, and we'll place it inside its respective field here in this script. So let's duplicate the spine rotation point, and we'll rename it to bullet shell spawn point. Next let's reset its transform, then we will manually adjust its position. And to do that, let's use the animation window, and then we will use the aiming animation clip. So it would be more convenient for us to adjust the bullet shell spawn point according to the position of the shell's ejection port on the weapon. And let's rotate it a bit for the z-axis to turn a bit up to give a arching trajectory to ejected shells, something like that. Let's select shooting point and drag bullet shell spawn point into its field to synchronize it with the shooting point so that it would eject those shells whenever this weapon will be fired. Thus, each time the shot will be made by this weapon, the bullet shell will be ejected from that position we have specified. And there's a few more tweaks for us left to do before we will do the playtest. Let's look inside find enemy script and decrease the field of view value to something like 200. And inside core AI behavior, let's disable all of those enabled behavior options for non-combat and combat situations, because they bring a lot of variety, especially when all of them are enabled. And what we need right now is to limit behavior of this AI agent to just shooting at the visually detected enemy. Let me close animation window. And one more last check here inside weapon. Let's make sure that the box collider is there, but it is disabled for the case when this AI dies. So it gets enabled, so the weapon gets unparented and falls down on the ground. So we're finally done with agent, and now is the time to create AI manager. Let's make an empty game object, call it AI managers. Let's reset its transform, and we'll create another child game object, and we will call it the humanoid AI manager. And to this game object, let's add the script with the same name. And the script info says that the humanoid AI manager script serves as a central manager for coordinating the behavior of humanoid AI agents within a Unity game environment. It optimizes performance by consolidating AI behavior updates and firing actions into a single update function, and handles the spine rotation updates in the late update function. This consolidation reduces the overhead of multiple update and late update calls for individual AI agents, enhancing overall performance. So you can see that the purpose of this manager is the optimization, and it might not be that noticeable in the scenes where you don't have a lot of AI agents, just a couple on each side. But it saves a lot of performance in scenes where you have much more agents, having like a couple dozens of them fighting each other, which could otherwise be much more taxing for mobile devices. So let's push play and see how the guy does in this first test. So the enemy AI agent detected us and opened fire as soon as he detected us and recognized us as his enemy. But we can also see that although this AI was set to perform fully automatic non-stop shooting until enemy dies or magazine goes empty, he is not doing that. This is most probably due to the vision obstacle enemy Raycaster intersecting with the collider of the head bone it was attached to. So in order to remedy that, we just move it a little bit away from the head bone like that, and this should provide us with the desired behavior so that the guy would shoot his gun continuously non-stop.
Suppressing fire. Reloading.
and this solved the problem. So when you will set up your own imported skinned meshes, and after setting them up like we did, you might want to check for this thing too, so that none of the colliders that are in the hierarchy of this AI agent would get in the way of that visual obstacle enemy raycaster. So I'm gonna copy the transform of this raycaster, exit the play mode and paste the values back, zero the rotations, and it's good to go. So depending on what you have attached to the head of the AI agent, maybe it is some kind of a night goggles or whatever it may be with the collider on it, make sure that this raycaster does not intersect with them. So let's do one more check after we've done that.
Suppressing fire. Reloading.
Okay, now it's working as expected. So that's gonna be it for this one, and see you guys in the next one.